welcome viewers to Faith Global Academy, and I'm your favorite physics teacher, Fred Mark. Today we're talking about motion. Our topic today is motion. Motion typically described in terms of velocity, acceleration, displacement, and time. Now, an object velocity cannot be changed unless it's being acted upon by a force. And that leads us to Newton's first law of motion. And then that's also called the law of inertia. Now, according to Newton's first law of motion, it says the body can remain in state of rest or continue to move in uniform motion unless it's being acted upon by an external force. Now, take for instance this blackboard. The blackboard can remain here for decades, for years, except a force is acting upon this body to change its position from where it is. It must be acted upon by force, or unless this body can remain here for decades. That's what Newton was talking about, and also called the law of inertia. The body can remain in a state of rest unless it's being acted upon by an external force. And that's what motion is all about. And motion is the change of a body, the change of a body position with time. The change of a body position with time. Now, it also involves how a body moves, and what makes that object to move. Why is the body moving? And what is making that object to move? That's what motion is all about. And there are 5 different types of motion. Number 1 is the random motion. Random motion. Random motion, another word for random is zigzag, haphazard, an object moving in a haphazard motion, moving in a haphazard way, a body moving in a non-orderly manner. We said that body is undergoing a random motion. When a body is moving in a zigzag way, moving in a haphazard form, in a non-orderly form, not in a linear manner, that means the body is undergoing a random motion. A random motion. In this movement, the particles are colliding. Now, a very good example of a random motion is the molecular movement of gas. Molecular movement of gas is a very good example of a random motion. And also, when you dash an object into the air, take for instance the feather of a bird. Now, if you throw the feather of a bird upward, notice that when it's coming down, it's coming in a zigzag manner. It's not in an orderly manner. And so that body is undergoing a random motion. Number 2, translational motion. The body moving in a fixed direction. When the body is moving in a fixed direction, we say the body is undergoing a translational motion. The body also moving in a straight line. Take for instance, somebody moving from point A to point B. The man moving from A to B in a straight line, that body is undergoing a translational motion. A motion in a fixed direction. It's not haphazard. It is not bent, but in a straight line. A car moving from one point to another in a straight line. That car is undergoing a translational motion. A boy running from one point to another, moving from point A to point B in a straight line. That boy is undergoing a translational motion. Somebody can run in a haphazard way, but that's a very good example of a random motion. And somebody can run in a circular way. And so, but for translation, it must be in a straight line. The body must be undergoing a straight line movement in a fixed direction. So we say that body is undergoing a translational motion. Number three, number three, okay, number three, rotational, rotational motion, rotational motion. When the body is going round in a circular form around its axis, that body is undergoing a rotational motion. The body is not going in a straight line, it's not going in a haphazard way, it's going round its axis, it's going round a circle. That body is undergoing a rotational motion. Now, a very good example of rotational motion, you say the blade of a fan, the blade of a fan. Notice the fan will go round, the blade will be going round. The blade is now undergoing a rotational motion. And also another very good example is the wheel of a car. The wheel of a car, the wheel of your tire of a car. It goes round, making a rotational movement. Now, an object can be operating on both levels. It can be going in rotational motion and also going in a translational motion. A good example is a car. The car could be driving straight. The car itself is going in a translational motion, but the wheel is observing a rotational motion, but the wheel is going round its axis. Another very good example of rotational motion is the movement of the earth around its own axis. Remember, the earth will revolve around its axis once every 24 hours. So the earth is also a very good example of a body or an object undergoing a rotational motion. So the blade of a fan is also undergoing a rotational motion. Number four, oscillatory motion. Oscillational. Okay, number 4 is oscillatory motion. Oscillatory or vibratory motion. They are the same. Oscillatory motion or vibratory motion. That is the movement of to and fro. The body undergoing a to and fro movement is undergoing an oscillatory motion or a vibrational motion. It goes to and fro. Take for instance, the motion of a simple pendulum. The motion of a simple pendulum. Let's take this as a meter stamp and then a thread. Now, this is assumed to be like a ritual stamp. Now, being hung with a thread connected to a ball, which is a mass. So when I give this mass a slight displacement, a little push, it goes to and fro, to and fro. So I body undergoing this motion is undergoing an oscillatory motion or a vibratory motion. It moves to and fro. A very good example is the wall clock. The old grandfather's wall clock we had in our house in those days that makes a sound. So if you look at it, has a very big ball at the end in the box of that clock. It goes to and fro. It gets to a higher point, come down to another position, then move again. So a body that is undergoing that motion is undergoing an oscillatory motion. Another example is a string of a guitar. The string of a guitar. So it moves up and down. It's not only to and fro. Even if it's up and down, it could be to and fro or up and down. So up and down could still be to and fro, depending on how the direction is. It could be up and down or sideways. So body undergoing to and fro movement is undergoing an oscillatory motion or a vibratory motion. Like I said, a guitar, the string of a guitar. So if you give it a slight displacement, it goes front and back, to and fro. Or a drum, when you beat a drum, when you hit the drum, it goes up and down. That body is also undergoing an oscillatory motion. That body is undergoing oscillatory motion. Any object that is going to and fro is not going in a zigzag way. It's not going in a straight line, because this one is not in a straight line. It's going to and fro. It could be an up and down movement. that body is undergoing, or that object is undergoing an oscillatory motion. An oscillatory motion. And number 5 is relative motion. Relative motion. Relative motion is the motion where an object is moving in relation to the other. Moving in relative to the other. Now, take for instance, a man sitting driving, and then when you are driving, you notice trees along the way, you notice some poles, electric poles along the way. As you are driving, it looks as if the trees are moving, but they are not moving. And so the car is moving in relative to that of the tree. So the tree is not actually moving, but it looks as if the tree is moving, but the car is the one actually moving. So the body undergoing such motion is undergoing a relative motion. But you also sitting in the car while the car is driving. Now you are watching from the window, it looks as if the poles are moving, the poles are not moving, the trees are not moving, the car is the one moving. You, the car, is the one moving, but the trees are not moving. So you are moving in relative to the motion of that body, which is the pole or the tree. Good. Remember I said relative motion is the motion of a body moving with respect to another that is fixed, and a body moving in relation to relative to another body. The motion of a body moving with an object that is fixed. Now, take for instance the motion of the body with respect to another body that is fixed. Now, take for instance a board. So I put let's say a moving object on a board, and then it's a string. Then drag the string. Let's assume this is a bed floor with a block on it, and then hook with a string. The board itself is fixed. The board is fixed. But the object, which is the, let's say, the wood on top of the flat board, is not fixed. This one is fixed. The board is fixed. Now, as you pull the wood or the board from this surface, now this movement is moving in relative to this other one that is fixed. So this is a very good example of a relative motion. Another very good example. Now take for instance a bus. You are in a bus and you are traveling, and the car is moving. Now you are sitting down and you want to walk towards the driver. Now let's assume the driver is moving with a speed. The driver is moving with a speed. So let's say 100 km per hour. The driver is moving with a speed of 100 km per hour. Now, the driver is moving with a speed of 100 km per hour, and then you, who is walking to the driver, is moving with a speed of yet, let's say with a speed of say 5 km per hour. Now, because you are moving in relative to the motion of the car, now so, okay, let me walk towards the car. Let me walk towards the driver. Sorry, let me move towards the driver. Now, you're going to add the speed of the bus driver to your own speed. Now, let's say it becomes 100. So you are now moving with 100 plus 5, which is 105 km per hour. 105 km per hour. Now the person now is now moving with a speed of 105 km per hour. The speed of the person, which is the speed of air, is in conjunction with the speed of the bus. So the person and the bus is an example of a relative motion. Now if the person is walking from the driver, and say the same speed of the driver is let's say 100 also km per hour, and the person is moving from the driver at say 5 km per hour. Now the super speed of the person is 100 minus 5, so the person is now moving 95 km per hour. The person is now walking against the speed. So they are both example of a relative motion. Now, a body moving in relative to the other, which is fixed. The person sitting or moving, and the bus driver driving, they are moving at a relative speed to each other. The person moving with a speed of say 100 km per hour, the bus is driving with 100 km per hour, and the person walking towards the driver is moving at the speed of 5 km per hour, moving with the speed of light also. Now, when you add it together, you're having the person that is moving with the speed of 105 km per hour because he is walking towards the driver. But so walking away from the driver, I have to subtract the speed from the speed of the person, which is 95 km per hour. And these are examples of a body undergoing a relative motion. A body undergoing a relative motion. A body moving with respect to another body that is fixed. I said before, a car that is driving, you are driving a car, you are sitting in the bus, and that the pole is fixed. The pole is not moving, the tree is not moving, they are fixed. So, but you are the one that is moving, the car is the one moving. So the bus or the car is moving in relation with the fixed object, which is the pole or the tree. So that body is undergoing a relative motion. According to nature of movement, motion is classified into three. According to nature of movement. Now, we have 5 types of motion: the rotational, the oscillatory, the translational, the relative motion. There are 5, but according to nature of movement, motion is classified into 3. That is linear motion, oscillatory motion, and rotational motion. Linear motion, oscillatory motion, and rotational motion. Linear motion is also translational, linear, in an orderly manner, gradually, in a straight line, in an orderly manner. I think the word orderly comes to play. In an orderly manner, in a linear manner. So that body is undergoing a linear motion. So we have 3 classifications of motion according to the nature of movement. We said number 1 is linear motion. Number 2 is oscillatory motion, which we have already discussed. And number 3 is rotational motion. When the body is rotating around its own axis. And we give a very good example of the Earth. The Earth is a very good example of a rotational motion because the Earth is rotating around its own axis. And also the wheel of your car, the wheel of the tire of the car is also undergoing a rotational motion. So we have 3 classes of motion according to the nature of movement: linear motion, rotational motion, and oscillatory motion. Oscillatory motion is the to and fro movement. Okay, now we talked about that motion is the change of position of a body with time. The change of position of a body with time. And how does a body change? What causes it to change? Why is it changing? What are the things that is behind it? Why will the body change its position? Now we said from Newton's first law that the body can remain in a state of rest, or the body will keep going in a rotational motion or a translational motion except it's being acted upon by an external force. And that is the cause of motion. The major cause of motion is force. Force is the major cause of motion. Cause of motion. Causes of motion. Force is the major cause of motion. You say the body can remain in a state of rest. And I give an example of a black ball. This black ball can remain here for decades, except something will cause this black ball to change its position. And then you remove the black ball from where it is. So its force is at work. So force is what causes the body to change its position or keep moving. The body can also keep moving. Take for instance the wheel of a car. The wheel of the car will keep rotating, keep moving, except when you apply a brake to the car to stop that wheel from moving. The point of the brake is force. So force is one of the causes of motion. Force is what causes a body to change its position with time. We said motion is the change of a body position with time. And what causes somebody to change its position is force. So force is one of the major causes of motion. When the body changes the body can remain its rest, or the body keep moving with constant speed or moving in uniform motion, except it's being acted upon by an external force. External force could be anything. It could be a brake of a car. It could be you pulling the object or pushing the object. I can keep this is a duster, it remains here. This duster can remain here for 10 years, except somebody comes and pull and remove it or push it. By pushing it, I have changed the position of this duster. By removing it, I have changed the position of this duster. So it can remain here except it's being acted upon by an external force. And that external force, that's what is the cause of motion. Force is one and the major cause of motion. Force is one of the cause of motion. That leads us to the effect of motion caused by force. What happens when force is applied to the body? Remember we said the motion is the change of the body's position with time. The change of the body position with time. Now, when force is applied to the body, what happens to that body? There are the effects of motion. Now, number one, the force can move the body. Force can move the body. One, force can move the body. Force can move the body. Like I gave the example of a duster. This duster is here. But if I pull this duster or push this duster, I have changed the position of this body. I have distorted this body. It's no longer where it is before. If I remove it, if I apply force by pulling it, I've also changed the position of this body. If I keep it while I'm holding it, if I put it now and push or pull, I have changed the position of this body. So when force is applied to the body, it tends to move the body. So when force is applied to the body, it tends to move the body. Now, another example, for instance, you are moving a pan is rotating one blade, which is rotational motion. And one of the force is like switch off the switch that is applying the force. It stops moving. The blade automatically stops moving. So that body is expected to have moved continuously in that motion, except the force is acting upon it to make it either stop moving or continue to move. The one is at rest. This duster is at rest. As far as anything that's rest is not moving. When we use the word a body at rest in physics, it means the body is not moving. Now this duster is at rest, it's not moving. So when I push it, it has moved. And the force has been applied. Now, if the duster is moving around, if I put a brake to it, it stops moving. I have distorted the movement of this duster. So it has also, by force, it has stopped moving. So force can cause a body to stop moving or keep moving. A body that is at rest, it can cause it to move. A body that is already moving, it can cause it to stop. So force is one of the effects. When force is applied to the body can move. The body can move. That's one of the effects. Number two, it changes the direction of the motion. Force can change. Force changes the direction of the motion. So when force is applied to the body will change. It can also cause the body to change its direction. This duster is here. Let's assume, okay, let me use the duster as an example. Now, a rotating fan or a rotating wheel of a vehicle, a very good example, rotating wheel of example. I can apply a brake to it and then it changes its position. It changes its direction automatically. Now, another example is the steering wheel of your car. is another example of a body undergoing a rotational motion. That its steering wheel is rotating around its own axis. Is rotating around its own axis. So with that steering wheel, you can change when you apply a force to it, you are changing the direction of that body or of that object. So when force is applied to a body, what happens, the effect is that force can change the direction of that body. Number three, it can also slow down. It can cause the body to slow down. To slow down or stop moving. When force is applied to a body, it can cause the body to slow down, what I've been saying before, or it can either cause the body to stop moving. To stop moving, when you apply a brake to a steering wheel, automatically the car automatically stop. And then if the thing is rotating, and then I place my hand on the wheel, it can stop moving. And so when force is applied to a body, it can cause the body to slow down or stop moving. It can even cause the one at rest to keep moving. Those are the effects of force. It can cause the body to slow down and cause the body to stop moving. It can cause the body to change its direction. It can also cause the body to move in the first place. Number four, it can change the shape of that body. It can change. Force can change the shape or distort the shape of the body, or distort the shape of the body, or you can also change the shape of the body. So when force is applied to the body shape can change. Now, a very good example, let's say anybody that is in a molten form, let's say a rubber band, sometimes elastic. So if the body is, the material or the object is at rest in my hand, the moment I give it a push, it slides. Now I have changed the shape of that body of being in, let's say it was this size. So when I distort it, when I drag the elastic material, it's now leaving its original position, its original shape. It's no longer being this size, it's a little bit bigger than what it ought to be. So when force is applied to this body, it now change the shape of this body from the normal position, from the normal shape it was before, to either a bigger shape or a smaller shape. So when force is applied to a body, take for instance also balloon. We have a balloon that has not inflated air into it. It's just the shape is just let's say an oval shape. And so when I inflate my air into the balloon, I have changed the shape of that balloon, no matter how it was before air enters it. So by putting in air, I'm applying force to that body, thereby changing the position of that body. Okay. Now before we go today, let's take the review of what we have learned today. We started with motion, what motion is. And I said motion is the change of the position of the body in time. The change of the position of the body in time. And I talked about how it also involves how the body change and what makes it to change. How the body change and what makes it to change. And that leads us to say that it was being allowed by first Newton's law of motion, which is also called the law of inertia. And the body can remain in a state of rest until being acted upon by an external force. And also we talked about the types of motion. And then we said we have 5 types of motion. We have the rotational motion, we have oscillatory motion, we have translational motion, we have rotational and then random motion. Random motion, we said, is a zigzag motion, disordered motion that is going in a haphazard way. Talk about rotational motion, the motion going around its own axis. And we give example as the Earth. Movement of the Earth is an example of a body undergoing rotational motion. We also talk about translational motion, the body moving in a straight line in a fixed direction. Like let's say a body moving from point A to point B is undergoing a translational motion. And it's also could be also called linear motion. And we talk about relative motion when the body is moving, it's relative to other body motion that is not that is fixed. And we give example of a boy in a car, in a moving car, a boy in a moving car moving. The car is moving, but the trees outside or the pole outside is fixed, is not moving, but the ball in the vehicle is moving in relative motion to the fixed object outside, which is either the pole or the tree. And we talk about also the classification according to natural movement, that the motion is classified into three: linear motion, oscillatory motion, and rotational motion. And then we also talk about the cause of motion. Why will the body change its position? And that leads us to the cause of motion, which is what force. It says force is one of the major cause of motion. The body can remain in a state of rest except it's being acted upon by an external force. Force can make the body to keep moving or stop moving, and those are the effects which we just discussed lately as the effects of motion. That when force is applied to the body, what happens to that body? One could cause the body to keep moving, or cause the body to slow down, or cause the body to stop moving. It also could change the body shape. The shape of the body can also change when force is applied to that body. And I gave a very good example of a balloon. You have a balloon that is deflated. The shape of that balloon is different from when there is air in that balloon. It's changed, the shape will change when force air is applied to that balloon. And so that's the topic for today, which is motion. Thank you.